Okay, lesson 4, polynomial long division. So there's a lot of times in math where we need to divide two polynomials, including some of our advanced factoring techniques. Let's start by practicing long division with integers. We're going to divide these two integers using long division. We'll state the result of the form of the quotient plus the remainder over the divisor. So let's do it. All right, the division algorithm. Perhaps you learned, do monkeys smell bad? And the answer is, I don't know. Maybe. Maybe to a monkey they smell delightful. I really don't, I'm unaware. But divide, multiply, subtract, bring down. All right, so 23 goes into 5,617, I don't know how many times. But typically the way we do this is we actually only look at the 23 and the 56. And we would say, well, look, 23 goes into 56 twice. So we'll put the 2 there. 2 times 23 is 46, and then we would subtract that. Now what we're really doing is we're saying that this is 200, and I'm really subtracting 4,600. That's why this works. When we teach kids the division algorithm, it's rather controversial because, the way we teach it, we break all sorts of rules of math. But we're not, as long as you understand that we're just not writing down the extra zeros here and here, okay? So then we try and, change it and make it more logical, and then we just confuse everybody. So it's just one of those things. Anyway, that becomes a 1, 0. 23 doesn't go in the 10, so I bring down the 1. Now 23 goes to 101, probably 4 times. And, you've probably had the pain of doing this and then finding out that, in fact, you didn't pick a big enough number. And you got to scratch out and go back, right? I'm bringing up some old wounds here. So 4 times 3 is 12. So that's a 92. So that's, what is that, a 9? So we did a good choice because that's, we got a remainder smaller than 23. I'll bring down the 7, and it's probably another 4 then, huh? So it looks like the answer is 244 plus the remainder over the divisor. Now you may be wondering, why am I not taking that further and making it into a decimal? Well, decimals are terrible, right? Fractions much better. This is 244 and 5/23. You want it as an improper fraction? There it is. That over 23. So that's just a process. So really, long division is really the process of changing an improper fraction into a mixed number. Okay? All right. So that's it. If you know how to do that, well, then I really don't have a lot to teach you today. And in fact, I will argue that what we're going to do today is easier than that. I think that stuff we just did is kind of hard. This is much easier. Let's divide the polynomials using long division. So I'm simply going to do this and divide by x minus 3. It's funny because I can't believe that I'm teaching this lesson today, because today in my AP Calculus class, I taught the integration technique of long dividing first. And I always wonder how they're going to react to it. It's like, okay, now sometimes you have to long divide first. And you know what? They said, oh, this is easy. Because if you can long divide, it just makes things so easy. All right. Yeah, it is cool. It's ironic that I was teaching on that day, right? Or coincidentally, I guess. All right. X squared divided by x. So when you're dividing long division, earlier I looked at just the 56 and the 23. We're going to do the same technique. Just look at the first term. But what makes this nice is there is no question about what it is. We're never going to accidentally guess wrong. X squared divided by x. Or x times what is x squared? X. That's the divide. Now I need to multiply, right? Multiply. X, so I distribute. X times x is x squared. X times 3 is minus 3x, and I change the signs. Oh, I haven't explained that yet. Now I got to subtract, right? So I divided and got x. I multiplied and got x squared minus 3. Now we have to subtract. It's easier to just distribute the subtraction. And you'll hear me say, now I change the signs. Which I just said. I forgot you haven't done this before. So I distributed the minuses, and the x squareds cancel out. Now, if they didn't cancel out, I've done goofed. 4x plus 3x is 7x, and then I bring down the 1. All right? We keep going until we can no longer divide by that. So I can divide 7x by x. 7x divided by x is 7. Now I multiply. Just the 7. 7 times x. 7x minus 21. But we need to subtract that, which is most easily done by just changing the signs. The 7x cancel, and negative 1 plus 21 is 20. Now x does not go into 20. Right? So we've got our answer. The answer is x plus 7 plus the remainder over the divisor. And there we have it. You may well have seen these. All right. So I'd like you to stop right here and practice a couple. A and B, please. All right, let's see how we did. So this first one here, x cubed plus 2x squared minus 3x plus 1, and we're going to divide that by x plus 4. X cubed divided by x is x squared. Remember, you just have to look at the first term. Now I got to multiply. I get x cubed plus 4x squared. And I change the signs. And what that gives me is a negative 2x squared. And you need to at least bring down the negative 3x. I usually just bring down the whole thing each time. That's just me. All right, now I'm going to divide negative 2x squared by x, and I would get a negative 2x. Negative 2x times x is negative 2x squared. Negative 2x times 4 is a negative 8x. And don't forget to change the signs. And that gives me 5x plus 1. So x goes into 5x plus 1 5 times, so plus 5. And I get 5x plus 20, but we got to change the signs for the subtract. And so we get a negative 19. So then this is x squared minus 2x plus 5. And just as a personal habit, when the remainder is negative, I still put a plus there and then a negative. And the reason why is on harder problems, you have to be real careful with that. So if I do it that way, it just always works. All right. So that's the answer there. Let's go ahead and look at the next one. We have x cubed plus 3x squared plus 4x minus 1. We're going to divide it by x plus 3. So x cubed divided by x is simply x squared. Then x squared times x gives me the x cubed. X squared times 3 gives me 3x squared. Then when I change the sign, something a little bit curious happens. We're going to lose both of those terms. That's okay. Don't let that bother you. Those both become 0. Just bring down the 4x minus 1. And what that means is we're going to have a kind of a gap in our quotient. We had an x squared. Now we're going to go all the way down, not to an x, but to a constant. So 4x divided by x is 4. And then 4 times x plus 3 is 4x plus 12. Don't forget to change the signs. And so we get a negative 13. So our answer is x squared plus 4 plus a negative 13 over x plus 3. All right. It is very helpful to use a zero coefficient for missing terms. This helps you keep things lined up. So let's take a look at this next example. You'll notice that I'm missing a term. I'm missing an x squared term here, and I'm missing an x term here. I recommend you use 0x here. Almost an absolute necessity, you use it here. So whenever look for that when you're doing division as kind of a first step that you fill in any missing terms. So this is x to the fourth minus 2x cubed plus 0x squared plus x minus 3. And I'm going to be divided by x squared plus 0x plus 2. And like I said, that one's not as big a deal, but it definitely helps. This one here, really want to make sure you have that. All right, x to the fourth divided by x to the second is x to the second. When you divide with same base, you subtract the powers. So 4 minus 2 is 2. Now, multiply. X squared times x squared is x to the fourth. X squared times 0x is 0x cubed. And I know that seems silly, but I like having that little placeholder there. And x squared times 2 is a plus 2x squared. But we need to change the signs. That one doesn't matter, but that one does. So that cancels out, and then this is just negative 2x cubed, and then negative 2x squared, and then plus x minus 3. And so you can see that just having those 0 x's really helped me keep things lined up and organized. 2x cubed divided by x squared is minus 2x. So negative 2x times x squared is a negative 2x cubed. Negative 2x times 0x is a 0x squared. Negative 2x times 2 is a minus 4x, excuse me. But I got to change the signs for the subtraction. And that gives me a negative 2x squared plus 5x minus 3. All right, last stage, we can divide negative 2x squared by x squared and get a constant of negative 2. Negative 2 times x squared is a negative 2x squared. Negative 2 times 0x is 0x. Negative 2 times 2 is a negative 4. But we know we changed the signs. So it ends up being 5x plus 1. So our final answer is x squared minus 2x minus 2 plus 5x minus plus 1 over x squared plus 2. If you're really careful, but it gets kind of ugly. There is another technique that we're going to learn later where if you don't add the zeros, you actually get it wrong. So I like to practice it here and just be consistent. But yeah, you could be really careful and avoid and still not do it, but nothing lines up right. So you just got to be really careful about combining like terms and stuff like that. All right, I have a couple more for you to do, please. Okay, so let's see how this went. Okay, on the first one, I am going to make this x to the fourth plus 0x cubed to kind of fill in that missing gap there, and then plus x squared minus 3x plus 1, and then I will divide that by x squared plus 2x minus 3. When I didn't give myself a lot of room to write here, did I? Okay, x to the fourth divided by x to the second is x to the second. So I get x to the fourth plus 2x to the third minus 3x to the second. And then we'll change all the signs here, which gives us a negative 2x cubed plus 4x squared minus 3x plus 1. Negative 2x cubed divided by x squared is a negative 2x. So that becomes a negative 2x cubed minus 4x squared plus 6x. But we need to change the signs, making this 8x squared minus 9x plus 1. I'll divide 8x squared by x squared and get 8. 8 times x squared is 8x squared, then plus 16x minus 24. And I'll distribute these negatives and change that sign. Kind of run out of room here, though. That's a negative, what is that, 25? Plus 26. Oh, plus 25. Thank you. All right, so our answer then is the quotient plus the remainder over the divisor. Now, one of the things I want to point out is this is why I don't like to do something cute like, oh, look, I got a negative here. I'll call this a minus. Because if I put the minus out here, I'm actually factoring it out. I'd have to make this a plus and that a negative. So to avoid that possible mistake, I always do plus, and I just write it down exactly as I see it, the remainder over the divisor. And I recommend you do the same. Let's take a look at the next one. Okay, we're going to divide 2x cubed minus x squared minus 13x minus 6, and we'll be dividing it by x plus 2. X goes into 2x cubed, 2x squared times, which gives me 2x cubed plus 4x squared, which I'll then change the signs to subtract. And now when I add, I get a negative 5x squared minus 13x minus 6. Negative 5x squared divided by x is a negative 5x. So that's a negative 5x squared minus 10x. It's not missing in the middle. I don't need a... no, either one.
So why don't we put like 0x to the 4 plus...
I don't need ones in front.
Because it's already there. And whatever's on the left side of the thing. If it starts with 1x, then you just need a number.
Like if I have the number 103, this 0 is pretty important. If I take it out, I just have 13. But if I have 0, 1, 3, I don't need that 0. That's kind of what it say. Okay, negative 5x squared minus 10x. I need to change the signs. Give me a negative 3x minus 6. X goes into negative 3x and negative 3 times, so that gives me a negative 3x minus 6. But when I change the signs, I actually get no remainder on this one. So it turns out that the result of this division is 2x squared minus 5x minus 3. Which means that if, another way of saying this is that if this divided by this equals that, then that tells me this times this must equal that. So in a way, we've actually factored this polynomial sum. So what practice 4.3b demonstrates is that x plus 2 is a factor of 2x cubed minus x squared minus 13x minus 16. And so we'll take this definition from here. We'll say a polynomial d of x, for divisor, right? D of x is a factor of a polynomial f in x if and only if the remainder when f of x is divided by d of x is 0. So to say that something is a factor is to say that when you divide by it, you get 0. Okay, so what I'd like you to do is to use polynomial long division to determine whether or not 3x minus 1 is a factor of the polynomial f of x shown. So I want to formalize polynomial division. Polynomial division is f of x divided by d of x equals q of x plus r of x over d of x. What that means is that if I multiply both sides by d of x, I would get just f of x equals q of x times d of x plus r of x. This is an equivalent statement for how to describe division. That I can say that q of x times the divisor plus the remainder is equal to the original question. This is something that you should be familiar with from regular integer division, so let's remind ourselves of that. I will refer to this often as quotient and remainder form. So let's take a look at 328 divided by 12. So 328 divided by 12. Looks like that would be goes into 32 twice, so that's a 24. And let's see here, that would be an 8. And I bring down the 8. And let's see, I think 12 times 7 is 84. So I get 27 plus 4 over 12. Or you might reduce that to 1 over 3. But let's talk about what's another. I'm not saying that they're like, I say equivalent. I'm not saying they're equivalent. I'm just saying they have, algebraically speaking, they carry the same amount of information. So what this is telling me based on this result is that I can describe 328 as 27 times 12 plus 4. In the same way that, if I say 8 divided by 2, and you say, well, that answer is 4, and I say, how do you know? You say, because 4 times 2 is 8, right? So 328 divided by 12 is 27 with the remainder of 4, because 27 times 12 plus 4 is 328. Okay. Let's do that with this one. All right, I'm going to long divide by x minus 5. And I get x, and I get x squared minus 5x. Change the signs. So I get 2x minus 10. 2x divided by x is 2. Oh, this is just got a remainder of 0, doesn't it? So it's a factor. So what I could say, though, is that x squared minus 3x minus 10 must equal x plus 2 times x minus 5. Now, if I had asked you to factor this polynomial, you probably would not have thought to pick a binomial and try long division, right? But that is essentially what we've been doing. And what my point here is that where we're headed with this is that while you could just factor that in your head, once you get up to x to the third, x to the fourth, etc., no, you can't. You need to resolve back to using just long division, which is we've really been doing this whole time, in a sense. All right, let's take a look at another one. X cubed plus 2x squared. And I'm going to say plus 0x minus 4. We'll divide that by x plus 1. This gives me x squared. X squared times x is x cubed plus x squared. We'll change the signs. I got that 0x as a placeholder. Makes my life a lot easier. X squared divided by x is simply an x. Multiply x times x plus 1. You get x squared plus x, and we'll change the signs. And I have a negative x minus 4. So that makes that a minus 1. Negative x minus 1. Change the signs. Gives me a negative 3. So how can I use this result to rewrite this polynomial in quotient and remainder form? Well, that form would be x squared plus x minus 1 times x plus 1 minus 3. If you multiply that out, combine on the like terms, and subtract 3, you'll get that back. And I'll leave that to you as an exercise. All right, so on letter D, let's take a look at that one. X goes into x cubed, x squared times. And I get x cubed minus x squared, but I change the signs. This gives me a negative x squared minus x plus 2. X goes in the negative x squared and negative x times. And I would get, let's see here, negative x squared. And then I think plus x. But I need to change the signs. Okay, so then I get a negative 2x plus 2. Negative 2x divided by x is a negative 2. And I get negative 2x plus 2. And when I change the signs, it gives me another remainder of 0. So what this is saying is that this is missing a 3 here, x cubed minus 2x squared minus x plus 2 is equal to x squared minus x minus 2 times x minus 1. We have, in a sense, factored it. We were able to factor this through long division. So on the exits, I got to ask you to redo that problem and try factoring it with grouping. You'll find that you get the same factors just in a different way because you can take this trinomial and go even further.